Connected to cloud server, and we're recording. Excellent. Unfortunately, this now means I need to trim off the bit where I say "and we're recording" off the start of the recording. Silly me. How long have I been using Zoom for? I don't remember that. Anyway, welcome to London DevOps, number 56. I found a new setting in Zoom today where I put the slides in my background like this, and so hopefully you can see me down in the bottom right-hand corner of the slides. If you can, then great. If not, then well, congratulations on not having to look at my face. Aren't you lucky? So we're going to kick off here with just a few introductory slides. Welcome to everyone who's coming to London DevOps for the first time, and thank you to all you old timers who keep coming again and again. Equally, very pleased to have everyone here on board with us here this evening. Welcome to lockdown 2. What are we, 3 or 4 days into it? Everyone's bored of it already, I'm sure. Oh no, not again. But then again, might be a vaccine. That sounds cool. So let's talk about London DevOps. So yeah, 56th meeting we're doing. We went virtual back in March for number 51. We managed to get to 50 before we all had to go and become hermits inside our own homes before going virtual. But we're still doing the virtual meetups once a month. Doing reasonably well with that, I think. Not quite the same. I'd love to see all your lovely faces in person, but we'll do what we can. So DevOps, here's my favorite definition of DevOps. I'm sure many of you have heard so many of these different definitions and have your own favorites and probably disagree with this one and agree with it in equal capacity. But there you go, DevOps, a culture where people, regardless of title or background, work together to imagine, develop, deploy and operate a system. From Ken, one of the senior guys over at ThoughtWorks. Sorry, I'm distracted because the waiting room thing isn't working, so I have to keep on clicking admit every time someone wants to come in. Reminds me of the time when somebody else was hosting the meetup and a physical meetup, and somebody would knock on the door every couple of minutes. I'm like, can I come in? No, you're late. Oh, well, I guess you can come in. That's fine. So that's what DevOps is. Maybe DevOps is about building a culture. I fundamentally believe that's true. All about people, process. And also tools. There's my diagram. I'm going to have to update that one. It's getting a bit out of date. There's so many tools around in the DevOps world that I'm sure many of us have encountered and used, but so many more since I put this slide together. So I imagine if we put them all on, the logos will be so small you won't be able to read any of them. So yeah, tools. We've got probably a bit more of a tooly meetup tonight. The last meetup we did was around emotional intelligence and teams, and you know a lot of the kind of softer skills that you need to do DevOps well. This one a bit more tooly. We're firmly in container world, and we're going to be talking about containers and security, probably amongst some of these other tools as well. So London DevOps, we formed. What is it, 2020? So 6 and a bit years ago now. London DevOps in its current state was formed thanks to Mark Cluett, who rescued the group from the doom of nobody wants to run this meetup anymore, which is an unbelievable thing to think in this day and age. But this is why we're here. We're here to share knowledge. We've got a great talk and hopefully a great panel session coming up afterwards. That will hopefully inform, entertain, etc., etc. Here to meet new people. That's quite hard in the virtual environment, but I'm sure you can wave to each other in the little Zoom windows. Please feel free to put your video on. It's good to see a little bit of feedback in terms of seeing your faces and seeing who's asleep and who's paying attention. No, but seriously, it's the only thing we've got right now. So please put your video on if you feel comfortable doing that. So yeah, we're here to help each other out. Many good working relationships have been struck up through this meetup in terms of people who have similar problems to solve or even just empathize with each other. Everything is shareable. We're recording this session, so you can come back and refer back to it later if you want to. But the whole idea here is that we talk, you hear things and you go and use that in your day-to-day, share the knowledge, unless indicated otherwise. So there's the Facebook channel. If you go to type London DevOps into Facebook. Sorry, I just saw Facebook in the top of that screen there, which made me say Facebook. YouTube channel. So yeah, go and look us up on YouTube, London DevOps. You can find recordings of pretty much most of the meetups that we've ever done are there. It's a great source of knowledge and entertainment for you. There's our code of conduct. We may be doing this virtually now instead of physically, but the code of conduct does still apply. We take it seriously. We have had to enforce it a couple of times, admittedly not in the virtual era, but we're not going to hesitate to enforce it if we need to. There you go. So we'll just leave that there for a few seconds for you to have a read. That's probably long enough. So the meetup. We couldn't really do this without the group of the four of us. Our various energy and busyness levels determine who actually does the hard work of getting the meetups done. And it's fair to say that without all four of us on this organising committee, that we probably wouldn't manage to do as well as we do. Well, I think we do well. I would say that. So if you don't think we do, then please write into us. So these are our organisers. If you've got any feedback of any sort, you know, we love hearing that we're doing a great job, but we equally love hearing things like what else you want to see from the meetup, things that we don't do so well, directions do you think we should go in that maybe we're not already going in. Any sort of feedback, please go and get in touch with one of us. So I'll just go around the room quickly. Around the room. Oh, I miss doing that. So Mark is here, but he's actually busy on something else right now. So I won't.
Yeah, I can say hello if you want.
Hello, please do.
Cool. Hello, everyone. Said welcome to London DevOps. Hope you're enjoying it from the comfort of your home.
There you go. So that's me. The second one along. The second one along. I've been called many things in my time. But never that. So I'll move on to Jack. So do you want to come off mute and say hello, Jack?
Hi, everyone. Thanks for joining us this evening. Thanks to our speakers, and yeah, hope you enjoy the event.
Sure, thank you, Jack. And finally, in the organisers committee, sorry about the bing bongs. Let me turn it down a little bit. Is Alex. Alex, do you want to say hello?
Yeah. Hi, everyone. Alex here. Hope it's a good event, and good to see some new faces as well tonight. So all good.
Thank you, Alex. Cool. So yes, we talked about sharing. Please do share stuff. Tweet out with our hashtag, which is in the bottom of every single slide, which you probably can't see because I'm in the way of it. There you go. Hashtag London DevOps. Maybe that's why nobody ever tweets or doesn't tweet as much as we'd like them to, because I'm standing in the way. But no, seriously, let's get some social stuff going on. On the Twitters, hashtag London DevOps, and we'll monitor that as the session goes on, and try and respond to you there as well. So as I said, organisers, very, very important. Sponsors as well, very important. So just run through our sponsors quickly. Firstly, Prism Digital. Alex, did you want to say anything?
Just briefly, that we're dedicated to DevOps and the DevOps and cloud market. We're talent partners. We're small. We care about our candidates and our clients and the people that we work with. So hopefully a nice experience to work with us. If not, let us know.
They won't let you know. Reader, they didn't let him know. No, they would. Thanks, Alex. Secondly, Adaptavist, that's the company that I work for. So at Atlassian Partners, we do a lot of digital transformation work as well, and everything in between. So come and talk to me about that sort of stuff. Just to put aside a preconception, I'm not actually a recruiter. I'm head of internal DevOps at Adaptavist. So if you want to talk techie stuff, then please come my way. There you go. Next, WeShape. Jack, do you want to talk about WeShape?
Yeah, I'll just say quick. So what we're a DevOps and cloud native consultancy. So if anyone's kind of looking for any kind of outcome-based contract work or permanent position, to give me a shout. But yeah, hope you enjoy the event.
Cool, thank you, Jack. Just to put another feather in the bow with WeShape. WeShape, or Jack specifically, also runs a community called London Tech Leaders. They're doing some really, really great work at the running events aimed at C-level tech leaders in the London area. So go and look that one up if you're interested. And O'Reilly, finally, they send us books and things and nice things that we hand out at physical meetups, which are now piling up presumably in Mark's house somewhere. Just a couple of community shout outs. Scale Summit is happening on Friday. So this is an event that's been running for a number of years now, run by this team, John Topper and Michael Brunton-Spall, I believe, is still involved in that. Used to be a one-day unconference down in the South Bank of London. Used to happen on a Friday in March. Obviously couldn't happen because of COVID. They've gone online, not entirely unconference. They've got some talks and an unconference element as well, I believe. But yeah, Topper asked me to give you a shout out, and I'm doing that right now because it's an event that I firmly believe in is really, really good value and a good experience for everyone. So there you go, Scale Summit on Friday, www.scalesummit.org. Also, Mark, are you able to talk to this slide, or are you busy? Mark may be busy. Okay, so I'll talk over this.
No, I'm here.
Sorry,
so this year we're organizing DevSecOps days again in London, but it's online, as of course we don't have any way to meet in person right now, fortunately. It will be called the DevSecOps Days UK. So it will be the whole of UK. If you register here, the tickets are in for an amazing economical price of £0. And the only thing that we ask is that you come in and enjoy the talks. We have some amazing talks reserved for you. We will announce the speakers next week, so be ready for that. And I said, if you want to sign up, go for it. It will be fun, and otherwise you get your money back. Thank you.
Excellent. Thank you, Mark. Okay, so today's talks. Maybe I'll try and get this thing to position me on the other side of the screen for next meetup. So yes, today's talks, we're going to start with Marco from the Scale Factory. I'm not going to attempt to say your second name, sorry. I should have checked that before, my bad. He's going to talk about privileged containers. I'm sure we're all aware what containers are. Actually, maybe we're not. Maybe Marco will go into that a little bit for us. But yeah, we'll talk about container and container security. And then we're going to follow that with, I didn't save the slide. We're going to do a panel session, which is not about EI because that was last month. We're going to do a panel session around whether the containers can ever have whether we can really accept containers as being as secure or secure enough compared to the likes of virtual machines and physical hardware, that sort of stuff. So we're going to do that. Thanks very much to Natalie and Ian, who I hope managed to come back. There he is. Yeah, he's in the list. Excellent. Going to be doing that panel session afterwards. So that's it for the introductory spiel. Please let us know what you think. As I said, great to hear if we're doing well, but equally we really want to hear constructive feedback about how the events are going, whether they're good, whether they're bad, what you want to do. And equally, if you want to speak or if you want to be on the panel, we know what we're doing next month. And in fact, I'll talk about that a little bit at the end. And that then takes us up to like Christmas time, but then we want to be planning January, February, March as early as we can. So we want to get the best speakers we can, the best panelists, etc. So if you're thinking like, I fancy doing some of that, or if you've got a tale to tell, then preferably a DevOps one rather than just a random bedtime story, then please do get in touch. Okay, so that's that. I'll stop that share and hand over to Marco, who is unmuted. That's helpful, good. If you want to start sharing, just make sure that works.
Absolutely. Thanks, Matt. Let me press some buttons here. All right. Hopefully people can see my screen now.
Yep.
If not, just shout. Cheers.
That's good.
Amazing. Cool. So thanks for the introduction, Matt. As Matt already said, it's going to be a little more tooly talk and less cultural talk today. I'm going to try to focus on the demo in the second half. So I'm just going to try to go through a couple of slides at the beginning. Just hope that a lot of people didn't just go like, oh shit, no slides, right? But unfortunately, this is how we are set for today. So what we're going to talk about today is literally about running privileged containers or running your workloads with privileged containers. And probably the main question for today is, who's afraid of privileged containers? And we're going to try to answer that as we go through today's presentation. So if you think of the containers of kind of, contain or, constrain workloads that you run in an isolated environment, you might think, okay, sure, if you're running it in an isolated environment, of course, the workload should be more or less secure and safe from any kind of, bad intentions from people that might abuse that fact, right? And if we look first at a couple of statistics, we would see that there is data from Sysdig. They conducted, I think it was a survey, and they found out that actually 58% of the containerized workloads nowadays are actually being run as root. So this means with the highest privileges. And if that doesn't kind of gives you the creeps, then definitely you there is additional piece of information that you should be also aware as that, by default, root inside the container also runs as root on the host. So for example, if you're not constraining your workloads in the containers, or if you're not careful about that, you might be exposed to different kind of privilege escalations that we will look into more detail as we go. So I would just like to kind of start out with a short Docker demo. So with what I have been saying. So what we're going to do is I have a simple repo here. It's basically what we're going to use later on for the rest of the demo. But first, what I would like to start with is I'm just going to run a simple Docker run container. It's going to be named Scary for the obvious reasons, I guess. And what we're going to do is we're just going to mount a volume under /x. And what we're going to do, we're going to mount our current working directory. We're just going to use CentOS 7 as a base image. Doesn't really matter which one you use for the purposes of this demonstration. And we're just going to execute bash, right? Nothing too scary so far. So as you can see, we are a root user within the container on the file system. And if we look at the mount points, oh yeah, I cannot type obviously. So if we look at the mount points here, we're going to see that we have mounted the /x. So let's just move there. And you're going to see the contents of the folder is the same as on my host system, with the difference that obviously the the user IDs and group IDs of the corresponding files are set to my UIDs and gets on the host. So we are root here, but can we actually do something on the host as we are mounting the volume? We can simply do touch, create a file, AA. I don't have really the more imagination here. So if we touch AA and list the file, we can see it's actually created by root, right? And by default, it has root permissions. So if we terminated the container, so if we check it out, it's stopped, it's gone. And if we list the file system on my host, you can actually see that the file that I have created actually has root permissions and a root git set. So that actually means that, for example, if you were to mount a sensitive folder, you might actually get access where you probably shouldn't get access to, right? Okay, that kind of cleared up the initial thing. So obviously we have to be careful about that, and that's going to kind of be a really good segue into what we're going to look for in the further talk, and we're going to expand it to Kubernetes, which is probably what all the cool kids are using nowadays, right? So before we really dig into it, thanks Matt for the initial intro. As said, I work as a senior consultant at the Scale Factory. We are a London-based DevOps consultancy, which really probably doesn't help us much being London-based due to the current situation, but nevertheless, we are also AWS Advanced Consulting Partners and Kubernetes service providers. I have to probably mention that we are also hiring if you are in that sense looking for new opportunities. I have a strong ops background, so I have plenty of experience in the system engineering design with extensive Linux and virtualization experience. And I am a really passionate open source contributor and supporter. And when I'm not working on IT related stuff, you can actually see me outside hiking, cycling, and traveling, which is also not happening right now. So just waiting until this is over then. Right, enough about me. So what topics we're gonna cover today? So first, I'm gonna talk a little bit more about containers, architecture of containers, how we run it, and then the orchestration of containers. So when you scale up the workloads running your containers, how do we actually efficiently scale up nowadays? Afterwards, we're gonna look into more detail of the security mechanisms available for us, either if we run containers locally using, for example, Docker, or if we're using any kind of orchestration system, such as Kubernetes, that we're gonna use as a demo example for today. Afterwards, I'm just gonna quickly go through the couple of escalation methods. So we're gonna look more into detail into two escalation methods. The first one, it's just going to be for, let's call it a warm-up. And the second one, the scary one, it's going to be the one that's going to be leading us into the demo later on. And because we're not just the bad guys, we're going to talk a little bit more how to do the remediation and avoid privilege escalation when you're running, or when you shouldn't be running, better said, privileged containerized workloads. And later on, I'm going to wrap it up with some conclusions and takeaways. Right. So as Matt said before, if some of you are not familiar with the containers or containerized architecture, let's quickly have a look what that actually means, how it's actually kind of built up. So from a really high perspective, we could say there are maybe 3 areas when you're running containers. So for example, we have a kernel level area where everything is being kind of laid out for us. So we are using kernel drivers, namespaces, control groups, and security modules to kind of ensure that we are isolated for other containerized workloads running on the host. The second bit, when we move up in the diagram, is the userland, so-called userland. So those are the tools that you would usually run from your either user shell or user interface. So those tools are using things. If you're using Docker, for example, they're using a daemon and the host called Dockerd, which is in the background using usually either a containerd or spinning up a runc or libcontainer. And then this would serve as kind of a manager for containerized processes, which run alongside the regular processes that you could also run on your host as well. And in order to kind of run your containers, you would usually pull your container image that you use when you spin up your container from either a public or a private registry. And you would usually use a client to do this. When you're using, for example, Docker, you would usually use a Docker CLI to kind of manage all this. So if you want to kind of, scale up and use that for production workloads across different environments, or even across different, perhaps, cloud providers, you would need to use something like orchestration system. So the one that probably survived the initial hype curve is Kubernetes. So more or less we are kind of stuck with that. If you are deploying that in productions, not saying this is the only way to go. There are still alternatives like OpenShift and others, but this is probably the one that has most traction, or at least it's most widely used nowadays. So how are we managing containers if we are kind of scaling it up? So in the containers, a Kubernetes environment, you would usually end up with at least kind of two things. So the first one is the control plane, which consists of storage part, which is usually etcd, which is a key value storage that's used. Then you would usually have a scheduler, cluster control manager, cloud control manager, and API server. So if you're, and then of course the cloud control manager kind of communicates with the cloud provider, depends on which cloud provider you're using. And of course, if you're using a hosted environment, that will also be kind of encapsulated away from you. And in this case, you would usually just run your nodes where you would usually have your kubelet and proxy running. And the thing that's kind of your entry point when you're spinning up your containers, which we will look more into detail, is kubelet. So its job is to kind of manage containers run on a specific node or host using an operating system there that can be, if you're using a cloud provider, usually on a virtual machine, not a physical machine anyway. Okay. So let's quickly have a look what kind of security mechanisms there are available for us if we are either running local containers or orchestrated systems. So for example, in Docker environment, you could probably look at running your containers as rootless containers. This means that the daemon running on the host would be running that on a limited privileges. So a really good kind of example for that is if you run instead of Docker using Podman. That's a kind of a really popular solution nowadays for rootless containers. Then the second thing there is probably considered as a good practice as well is we would usually drop container privileges that are unnecessary. For example, like system privileges or any kind of privileges that will give you more permissions than needed. Of course, you can also kind of limit the exposure of the daemon endpoints if you're running Docker. So for example, instead of TCP or TLS connections, you could use local sockets. That kind of limits the security footprint there. And of course, there are some kernel security features available for us out of the box as well, like AppArmor or SE Linux or SecComp that comes with Docker if you're using that solution. In the Kubernetes world, there are different things how to secure your workloads. So we would usually secure our endpoints. So the API would probably not be publicly accessible, or if it is, we would use security groups or IAM in case of AWS to secure the access to that. And worker nodes would probably not be exposed as well. Then, of course, there is RBAC, so role-based access control, which we would set up and set the granular control for our users to gain access only to resources they need access to. And if we're using CI/CD pipelines, there are different kind of policies or pipeline steps that you can put into place where you would probably scan your manifest and manifests or containers before actually spinning them up. And there are also things like you can utilize the admission controllers, for example. You could use Open Policy Agent to achieve that quite nicely with the Rego language, or you should probably look into the network policies for kind of doing the firewalling within the Kubernetes, or the thing that we're gonna look more into detail, which are pod security policies, which offer kind of wide variety of things that we can actually prevent with out of the box from Kubernetes without need of having an external or third-party solution there. Okay, let's quickly look at our two kind of escalation methods we're going to look today. So the first one, as I mentioned, is maybe a little bit kind of I like to call it a boring escalation method, but nevertheless, it's quite an easy one to achieve, specifically if there isn't anything specific put in place for your Kubernetes workloads. So just for the context, if we have a normal user that is authorized to create resources in their own namespace, we can actually access to all currently mounted secrets from the host mount point. And in order to achieve that, we could just run a pod that bind mounts from the host kubelet directory and just read those from those mount points, right? So how to achieve that is as simple as run kubectl. As I said, we can use any kind of image that gives us shell access. So in this example, we're using BusyBox, just executing a shell. In the next slide, I'm going to show you what override JSON is. But before we do that, just kind of to expand on that. So not only we can actually look at the secrets on the specific node with this method, is if you run this pod as a daemon set, you can actually grab secrets from every node running that pod, right? So escalation from here really depends on what you're running on the specific node and what you can actually scrape for. So by default, nothing in AWS EKS that allows further escalation, but I mean, for me, that seemed quite a big one if you're not properly kind of watching out for this. So as I promised, let's have a quick look at the override JSON file. So how we actually achieve that, we are overriding the specification of our pod, and what we are doing, we are using volume mounts specification, and we are mounting our kubelet volume to /var/lib/kubelet. And we are using a host path to kind of mount that volume into the container, and using the same path on the host, which is a standard path where Kubelet is storing secrets, Kubernetes secrets on the local node. So as you can see, it's quite an easy way of scraping for the secrets from all your nodes, unless you're already protecting against that. Okay, let's look at the second escalation method, which is a little bit more interesting or / scary. So the context is still the same: authorized user, able to create resources in the namespace, and has some kind of cluster API access, right? So either with kubectl or through the pipeline, which is not actively checking for privilege workloads. So we're going to run a privilege pod with a common modern Linux distribution as a container image. And the question here is really, can we escape the container boundaries here? Because as we have seen before, if we're running a container, for example, locally on our Docker daemon, we can easily use root privileges within the container on the host, and actually read or write to the locations that we weren't supposed to. So the question is, can we actually do it on orchestration platforms such as AWS EKS? A little bit of spoiler alert: yes, we can. By running a privileged pod, we can actually elevate all the way up to the node root, and this enables us to check for the, for example, EC2 instance user data. We can see how the node was bootstrapped, inspect what containers are running on it, and, for example, grab the private key material and the kubelet's kubeconfig, which enables us to actually bypass the whole RBAC system and elevate all the way up to the cluster admin if we're not actually protecting our workloads. So that basically enables us to gain the whole cluster access, so admin access, and gain full control of the cluster. So as I mentioned in the intro, let's see what we can do to prevent that. Like I said, there are obviously different approaches how we can attack that or prevent those things. Today, we're going to look more into detail in pod security policies. So in a nutshell, in order to use the pod security policy, we need to have a role or a cluster role and a cluster or a role binding assigned to a user group we're using. And the thing we should be careful about is ordering is important. So how it actually works, the pod security policy controller goes through all the security policies and tries to validate through them. And when it finds the first one that matches a current user or a service account, that one is applied and it stops there. So there is a little bit different logic that, for example, people might be used from, I don't know, firewalls, where they would go through all the rules and probably the last one matching would apply. So using pod security policies, we can actually validate against mounting host paths, using host network, or even privileged mode. So by using a pod security policy, we can actually successfully mitigate against previously mentioned escalations. Another thing I want to point out at this point is that if you're going to use AWS, pod security policies in AWS EKS, there is a default one deployed, which is called EKS.privileged, and by default allows running everything. But if you're gonna amend that one, please do it with caution, as it can actually break your cluster to a point that you would need to reprovision your whole cluster. So you could actually lock yourself out of the cluster or end up in a state that you wouldn't be able to, for example, join new nodes in or recycle existing nodes, right? And of course, there is further hardening locking we can do. For example, like, make container file systems read only, prevent running as root within the container, or drop specific or all capabilities of the container. All right, before we dig more into the demo, let's just quickly go through the demo context. As I said, we're going to run currently latest AWS EKS cluster 1.18. I've just bumped that yesterday in my demo, so let's just hope they didn't mitigate it out of the box. We're going to run managed node groups. It does work for unmanaged as well. If you're running Fargate workloads using EKS, that's protected or prevented out of the box, because there are some limitations of when you're running Fargate workloads, for example, such as you cannot run privileged workloads. Then worker nodes will only be accessible on private subnets. We will have RBAC enabled cluster-wide by default, and the user we're going to use is going to be constrained to its own namespace using RBAC. So let's go and try to escalate our privileges now and gain more control. All right, so we are still in the same repo. Just gonna remove my previously created file. And so first, okay, let's start with this. So what do I have here is I have deployed EKS fresh Kubernetes cluster, as I said before, 118 actually. If we check the nodes, they have been, they're managed nodes running 118, and we are running a Kubernetes cluster on the specific endpoint, and the core DNS is running as well. So if we check, there are default pods running there, nothing too fancy, just an AWS node pods, core DNS, and kubeproxy on each of the nodes. It's a 3-node cluster, and it's completely empty at this point. So if we have a quick look here, as I mentioned before, there is a default pod security policy that's applied out of the box, and it does allow running privileged containers, doesn't limit any capabilities, and literally allows everything to be run out of the box. So what we're gonna do first, we're gonna deploy a user and a service account we're gonna use to kind of simulate or fake a user that's gonna be limited. So just to imagine what we're gonna do, because obviously we don't want to amend cluster-wide policy, we're gonna create a service account and a role binding for that specific user, which is gonna be validated against the pod security policy we're gonna create later on. Okay, so let's just apply that. Just a quick check. Hope everything makes sense so far. If there are any kind of questions, if I'm going too fast, please stop me at any point, or we can take questions at the end. Reassuring silence, perfect. Cool. All right, so we have deployed a user. Let's look at our pod security policy now. And what we're gonna do here now is we are deploying a manifest, which is type of pod security policy. We're gonna call it, surprisingly, EKS.limited in contrast of EKS.privileged, which is also already deployed. And what we're gonna do in the specification is we're gonna prevent running privileged containers And we're going to prevent allowing privilege escalation. We're not going to allow any capabilities or host network and mounting specific volumes. So we're going to cover all the things that we kind of seen in the previous slides. Okay, let's apply that now and check that we have a policy in place. Policies in place, perfect. So the next thing we're going to do is, I promise, it's the last manifest we're going to apply. So I know people hate YAML, but I'm trying to keep it to a minimum as possible. So what we're going to do here, we're just going to create a cluster-wide role just for the sake of the demo. You could obviously just create a role. And because for the sake of simplicity here, what I'm going to do is I'm just going to override, actually, this is not creating a new role. I'm just kind of tweaking it a bit. So this is actually an existing cluster role, which is called EKS pod security policy semicolon privileged. I'm just going to override what this cluster role is actually being validated against. So by default, it's being validated against EKS privileged. What I'm going to do, I'm just going to override it and say, okay, instead of privilege, let's just use EKS.limited now. And let's just do that now. Right. So it was just reconfigured. And before we go further, I'd just like to show you I have a couple of bash functions because it's probably easier to to use those rather than type all this for my demo. So I have two simple functions. The first one is called shell-u for shell unlimited, and second one just for shell. And the difference is for the first one, I'm using a default service account. For the second one, I'm actually using a service account which I just created, which is called a fake user. And it's going to use a pod security policy that we defined. And what we are doing here is in the specification, when we're spinning a container image, which is CentOS 8 in this case, what we are doing is we are overriding our spec. And what we are doing is we are actually using a security context with privilege true, which will enable us to escalate our privileges here. Okay, so we have deployed things. So I'm just going to start with the unlimited thing, which is not going to block us. And it will just drop us into the shell of the container. So we are root on the container running in the pod. And if we look, we can see obviously it's a CentOS 8 and it's a standard kind of CentOS 8 layout, nothing really specific about it. But what we can actually do is, because this is now run as a privileged container, we can actually use a tool called ncenter, which is a tool which enables us to run processes in a namespace of a different process. And what we're going to do in this case is we're just going to use a namespace of a process with PID number 1. And PID number 1 is our initial process that is spun as root. So I'm just using this one because I know this one is using root. And what I'm doing is just spawning a shell and using bash. So if I run this, boom, I'm immediately switched to a different namespace. And this is a namespace of my host root. So as you can see, my host name has changed. So obviously something's different, right? So if we check the etc OS release, you can see now we are on Amazon Linux. We are not on CentOS 8 anymore. And if you look at the structure, you're going to see it's a bit different, right? And what else we can do, because this is obviously a host now in AWS, we can also query for user data, right? So let's see what we can actually query. Nice, right? We can actually see the cluster CI material, which is kind of cool. It's actually base 64 encoded. So I'm just going to decode it just to show you that it's actually not that complicated to do so. We're just decoding it, and you can see it's actually a CI certificate for the for this node when it was spun up. And if we use, for example, because I know that we are that AWS is using Docker as its foundation to run containers, we can also do Docker PSA, and we can actually see all the containers running on the host. And this is actually our container, which is actually a scary shell default container that has spun up. And we can also see there are different containers running there as well. For example, like kubeproxy, CNI, AWS Node, and others, right? And we can even go further than this. So for example, we can go to varlib kubelet, and actually get the kube config from the kubelet. So kubelet actually runs as a cluster admin or connects to API as a cluster admin. So we can actually use we can actually use that kube config to elevate our privileges all the way up to a cluster admin with the authentication of kubelet, and basically create anything we want on the cluster now. Okay. I hope this wasn't too scary. Probably a story for Halloween, but we are a bit late with that. So we managed to get our all the way up to the cluster admin, and probably now the real question is how to prevent that, right? So if we go back, I just exited out of my host, exited out of my shell. I'm back on my repo, and what I can actually do is, let me first show you. Just going to go to functions again. So what I'm going to do, I'm going to show you first that I've actually created that user. It's not something that I made up. So running as that user, you can see I cannot see any pods because in my default namespace, there aren't any pods running. If I try to query for all the pods, obviously I'm limited. I don't have permissions to do that. Or if I want to do get nodes, I get a similar kind of message, which is saying I have access denied for the listing nodes resources in the API group. So let's try to use that user now. I'm just going to run my shell function and try to use that user to actually run my privileged container now as well. And it's going to be validated against the pod security policy that we deployed. And you can see that immediately, boom, we have been denied by the pod security policy validation, saying that it's unable to be validated against any of the pod security policies attached to that user. And in this specific context, we have been denied because there is an invalid value on the security context host bit, which is set to true. So yeah, the privilege is set to true and it's an invalid value. It should be false. So privileged containers are not allowed in this case. As you can see, it's quite easy to implement this technique to kind of prevent this kind of escalations or prevent users being able to progress their or escalate their permissions all the way up to the cluster admin, even if they don't have that access out of the box. Cool. Right. So moving back to our presentation. Promise, there is only a single slide left. So for the conclusions, container orchestration platforms are quite nice. They usually come with batteries included, for example, like EKS, but we should definitely be aware of cloud share security model and what kind of falls underneath our responsibility and what is taken care of the cloud provider. And we definitely need to make our security a first-class citizen and not kind of push it in the background, and be aware of that and watch out for all the different kind of escalations or privileged workloads that people might run either unintentionally or intentionally. So out-of-the-box security is usually remote exploit safe, as far as goes for AWS EKS. But if people have API access, like we've seen in the demo, obviously they can escalate their permissions all the way up. So to cover the basics, you need to protect your crown jewels, in this case, control plane worker nodes. Try to run your containers rootless, so least privileged pods, worth changing the default. So by default, EC2 credential access is available even if you're running your EKS workloads. so it's worth limiting that as well. Definitely use namespaces, as you probably are aware. And as a very good strategy there, and our recommendation is to enforce the streamlined pipelines. So try to avoid direct kubectl write access, and scan for vulnerabilities and regular check for updates. And if there are any takeaways that I would like to take you from there, is those two things. Kubernetes airbag is really complex, but it's not good enough on its own, and everyone should be afraid of privileged bots, to answer the initial question there. So with that, I'm gonna wrap it up with some further reading. I'm gonna make this presentation available. There's gonna be a video available afterwards as well. And please do get in contact. I'm happy to answer any questions people might have right now, or just please contact me later on, either via social media or the website. So thank you for your attention, and back to you, Matt.
Great stuff. Thank you, Marco. Thank you very, very much. If anyone wants to just come off mute and give me a bit of applause, then I'll start that off.
Thanks, Marco.
Thank you.
Excellent. Great stuff. Yeah. So we were talking about, do we need to be scared of privileged containers? I'm now thinking, yes. Oh my God. Brilliant, brilliant, excellent demos, excellent explanations of things. Thank you, demo gods, made everything work. That's never something to be taken for granted. So,
Absolutely.
does anybody have any questions before we move on to the panel, which is talking about similar sort of things? But has anybody got anything directly for Marco? Oh, I see one from Oren there in the chat about equivalent resources for Azure. Is Azure something you've ever touched, Marco? Want to
not really, but I'm assuming they're running Kubernetes relatively in a standardized form, so you could still use pod security policies. Probably one of the reasons why I went with out of the box, or why I wanted to explore what's in there out of the box, right? Because obviously there are third-party solutions you can use, like I mentioned, either a OPA, admission controller, or things like Falco, for example. But I think there should be, pod security policies available in the Azure as well.
Good stuff. Okay, brilliant. Okay, so thank you again, Marco. So Marco's going to stay on and come on the panel. So we're going to do another panel session, which in hindsight, when I'm trying to think of when we're trying to think of things to do panels on, we generally want to have a little bit of contention, a little bit of controversy, and I'm not sure we quite got that with this this panel session topic. My fault entirely. But we're going to go for it. We're going to have a little chat around container security and the implications of running containers on cloud services, and whether as an old boss of mine once said to me, why would you run this stuff in containers when we can do it in virtual machines and segregate things properly? How much of that is true? How much of that is real? How much of it is FUD, etc. So I'm going to introduce panelists who very grateful to them for giving up their time to do this. Everyone on short notice as well, because we're not very good at organising things with long notice. So I just want to go around in turn, and if you want to just come off mute and introduce yourselves. I'll start with Natalie. Did you want to say hello? Who you are, what you do?
Yes, sure. Hi, I'm Natalie. I'm a platform engineer at Babylon Health. I've worked with on-premise data centers, spent about 1.5 years building secure Docker platform at Morgan Stanley. And now in Babylon, we run everything on AWS and GCP. Everything is in EKS. And yeah, containers everywhere.
Yeah, containers. Thank you, Natalie. And secondly, and I'm going to hope this works, because as I said at the start, we lost a panelist earlier today, and then Ian comes on to me and says, my DSL is flaking out. I get kicked out twice. I'm like, oh my God. So hopefully, can you say hello, Ian, and who you are and what you do?
Yes, my connection is held together with string, but it seems to be working.
So yes, my name's Ian Mile. I work for Container Solutions, where we help customers with cloud native transformations. Formerly, I worked for banks, trying to get basically telling people they couldn't have Docker on their desktop, which they all wanted, but they had to use a centralized platform, which was highly secured. And yeah, so I'm slightly, yeah, well, we can talk more about it, but yeah, it's
Sounds like a story in itself, that one.
yeah.
Okay, thank you. And also, I'm just hit up Brian. Brian, are you there?
Yeah, I wasn't sure if you still wanted me to do it.
I do. Well, Ian's here, but we always want to hear from you as well. So yes, I lined up Brian as an ultra last minute possible replacement for Ian, but always willing to add more people to the mix. So Brian, do you want to say hello?
Hi, yeah, I agreed to this 5 minutes ago. So Brian Mywick, I'm IT consultant or DevOps consultant, doing everything automation. I moved to Amsterdam in April, so the fact that it's online now means I can still attend. I've been, for the last 6 or 4 months, I've been working for 2 people at the same time. So in the morning, I've been doing AWS and then AKS and Azure in the afternoon for Deloitte and then for ClubSpark. So so I've trying to split my time, and it's been, yeah, anything containers and automation is what I do.
Brilliant. Thank you. Thank you so much. And yes, it was literally 5 minutes ago I asked Brian. So congratulations on the move to Amsterdam. I didn't know about that.
Thank you.
Mark, are you also around or are you still busy?
I'm kind of busy, but kind of around, kind of both, in a quantum state of busyness.
Cool. Okay. All right. So we'll kick off the panel. So yeah, we've talked about VMs and containers. Marco's showed us things that will keep us awake at night of container exploit. Well, not necessarily exploits, just how these things work by design. So I wanted to just start by asking the panel whether you've ever had any of those sort of discussions, like we can't run containers because they're insecure. You can't do it. We're not going to be doing any of them. Stick to your nice EC2 VMs or physical data center machines over there. Is that something that resonates with anyone at all?
Yep.
What are the reasons? Do people? Is there any kind of flexibility that people have there, or is it just a loss? What do you think, Natalie?
So
Sorry. I've certainly faced loads of that in my banking days, and big corporations, everyone is always scary. And also it was maybe 2 or 3 years ago, so people weren't as comfortable with Kubernetes and orchestration and all of the platforms. So for everyone who comes from a traditional VM background, you show them something like we saw at the demo, and it's very, very scary. And people start talking about patching their own Docker daemons and stuff like that. Because these vulnerabilities are fairly easy to exploit for everyone who wants to, obviously. So yeah, loads of arguments.
I've found that a lot of clusters, if they, especially, so my current deployment with Deloitte is to an Australian bank, and the key was everything has to be private. So you can still run it in containers, but the containers have to be private. The cluster has to be private, and all the containers, the registry has to come from a private registry, and everything has to be pre-scanned, and nothing is allowed out. So I found that when you're looking at a lockdown environment, is making it all private has kind of broken down a bit of those barriers, I think.
Gotcha. Ian, do you have a perspective?
Yeah, I've spent a long time wrangling with security departments at banks, and the main difficulty is, I think, that the discussions get quite nuanced. Whereas if you're looking at VM, it's conceptually quite simple. Once you trust the hypervisor, you're done. You're happy with it. And you know, we've got 15, 20 years experience of dealing with VMs, and nothing terrible has happened recently, as far as I know. Although there are still hypervisor exploits that come up. But anyway, people are comfortable with that risk. But when Docker came along and when I was having these conversations, it was striking how often you got into the weeds, and they started talking about, oh, there's capabilities and there's privileged and there's this, that, and the other, and how does this affect it? And suddenly you're drawing a matrix of possible risks rather than a simple statement about a single thing like a hypervisor. So yeah, it was interminable discussions we had around security, and then on the other side you had the developers who just wanted to use Docker and didn't really care about any of that, and you had to sit in the middle. Well, I had to sit in the middle in the infrastructure team and sort of negotiate between one side and the other, and it was definitely one of the big subjects.
So that's an interesting thing you touched on there about how everything is so nuanced, and there's so many different elements of that you need to go and turn off or turn on to make these things secure. And so again, a more general question to all of you. I don't know who wants to pop up first. Do you think? Well, I sometimes sit here and think, why didn't they just make this stuff secure by default? Is that even a possible thing to do? Do we think, or is that just crazy talk? And then in order to be able to do things well, you need to be able to understand all this nuance and turn the things off that shouldn't be on in the first place. Anyone got any thoughts on that one?
Well, if they is Docker, then
Yeah.
I guess they just wanted something that worked, because I think it was originally built for a company for internal use, right? Dot Cloud, whatever they were called. So they probably didn't really give two hoots about worrying about whether you could run as root or not. And it's the same with all software that I'm sure we've all written in our startup days or anything. You worry about security last. So I think that's where that's come from. Also, it's hard. It's difficult to write SE Linux. It's difficult to write things securely from the ground up, and it generally doesn't happen unless you're writing something for that purpose, which Docker certainly wasn't.
Yeah. I think thinking about security last, I think the solution lies right in there. If we think at least a little bit about security from the very beginning, then all of these pod security policies and seccomp profiles and Docker daemon D. So for the Docker perspective, you can secure the daemon, and then think about containers also. Those things have been developed by the community throughout the years, and there's lots of things out there that you can just grab and implement but you have to do it from the get-go. You have to think about it before you've done the whole thing and have 15 clusters.
I think it also comes down to the merging of roles. So, I mean, I never used to be a security person. I still don't think I'm a security person, but I think it's the merging of roles of building up environments where people building environments, some come from development background, come from sysadmins background, and a lot of people don't put the emphasis on security. But I'm thinking tooling is closing that gap. The open policy agent, I think, is becoming easier to use, which I found for my previous project. And I'm thinking with tooling and that making it easier, I think more people will adopt it as opposed to leaving it to last.
I think there are some really good points here, but for example, I still think we have two sides of the coin here. So for example, if you take those big companies as banks or highly regulated industries as pharma or something like that, they would probably start with the security in mind from the get-go. But I think the second part of the spectrum is probably like startups, right? Where they try to push their product to the market as soon as possible. And I think this is the reason why security is usually pushed aside, where, they want to push the product out. And, you have to cut some corners to achieve that, right? You cannot do everything out of the go, because it's such a competitive market. And if you don't do that, probably you're not the first out there. So I reckon this is the reason. And of course, like I said, it's hard at the same time. So probably you try to do easy stuff first. And at the same time, like you said, Matt, I think Kubernetes is such an kind of open and configurable system that there are so many things you can do with it. It's probably impossible to kind of do it secured out of the box, because it wouldn't fit so many use cases in that case. So.
Do you think there's maybe I think there probably is an opportunity here for things, Kubernetes builds that you can either buy or download or run that have a lot of these things turned on by default. So, for example, I'm thinking of like OpenShift, which I think doesn't actually let you run containers that run as root unless you go to great lengths to turn that off. Do any of you see those sort of value add services as being something that we should maybe just have by default on a Kubernetes installation, or on AKS or EKS, GKE, any of those things? Or is the power of the platform the ultimate thing that we should let these things we should let developers make their own choices on them?
Potentially, yes. If I suppose OpenShift manages the things like routing and proxying out of the box, so you don't have to worry about running daemon sets that need to be run as root. But also, if you do need to run something that needs to run as root, then you're in a bit more of a trouble. I guess it's a trade-off of what you want to manage and what you can just give away. Like in EKS, like an example for why networking and routing, in EKS they don't provide Istio, so we have to run Istio, and that needs to potentially run as privileged. Whereas GKE has managed Istio, if I remember correctly, or is that Anthos? But some.
Yeah, but you would think eventually they'll all get there. I do think it's in their pipeline that they have to get there eventually, because I think a lot of them, especially if you're doing the GKE, AKS, EKS race that they're busy doing to fighting for everyone's business, I think a lot of functionality is rushed, and then in Azure, AKS, a lot of things in preview. You would think a lot of functionality that should be there is in preview. And then some functionality, like you say, managed Istio in GKE, you would think EKS would have that. So I think they're adding so much to their tool set that I don't think they're focusing enough on getting the Kubernetes and all the security piece of it that I think should come standard.
Maybe that ties in, Brian, with what we were saying earlier about you've got startups who want to get stuff out and security comes last, and maybe that's a similar attitude coming in from the cloud providers, right? Yeah,
but you are also seeing from big customers before they're signing, or those startups when they're selling their product, I'm seeing a lot more with regards to startups. Their products need to have like CI's benchmarking and everything signed off and meet certain standards before they would get a long-term contract. So I think there's a lot more of that businessy stuff that's coming into driving the contracts from startups. But then at the same time, a lot of people are throwing money at startups because a lot of them have got good ideas. So it's getting that balance, I think.
There's an interesting discussion on the chat about culture versus tooling. And I think, like, I come from infrastructure, so a lot of developers oftentimes don't think or don't know as much as like DevOps and DevSecOps people do about security. And maybe there is a risk if we do have tooling that has all of the security stuff built in and just exists, don't we risk people not even thinking about educating themselves on security?
I mean, culture is people say you can teach culture. I don't know. I think it's just built into some people with regards to the sharing culture and educating and being collaborative and that. I think most people in our industry can learn tools. I still think not everyone can learn the culture.
Yeah, but you have to think as well that humans in general don't like change. We don't. I mean, we animals of habit, right? So in order to change the culture, you need to ingrain that change and do it in a way that it feels safe. So that, I mean, I've been successful in some places. Some others have been extremely difficult to change that culture, but it's still possible to do it. But I said, it just depends on how much people are ingrained into the way of doing.
Yeah, absolutely. I think we should probably look at Kubernetes as it's not an end game, right? I mean, there are obviously things coming out from the cloud vendors as well. So if you look at AWS, we're obviously partnered. That's why I'm talking mostly about them, where they just released the instance enclaves now, so you can do a lot of interesting security stuff there. So there obviously is option to secure your workloads. I just think Kubernetes is just a stepping stone where we will probably add more, not complexity, but higher level of abstraction at some point, which will include a lot of those features out of the box. So I don't think we're there yet, but I think there is a positive trend going there, though.
I think you have to give props to Red Hat and OpenShift for nailing that market very early on in terms of security and enterprise. There should be 3 or 4 Kubernetes distributions that are enterprise ready, and yet OpenShift seems to dominate that market. And I think the amount of effort, that money that Red Hat spent getting the security story right is not often appreciated in the industry. I often flip between talking to enterprises who like Red Hat / IBM and engineers who hate them, and there's a huge gulf in understanding between them. The engineers think that Red Hat are money-sucking parasites, but on the enterprise side, they're seen as the good guys because they actually solve all these problems for them, and they're not happy about handing over the money, but they certainly see that there is value in what they do. So I think that cultural difference I find really interesting in the security discussions that I've had.
Without wishing to sound like a Red Hat fanboy, which I definitely am not, I kind of do approve of that from a cultural perspective. But there's also the technical perspective. I'm wondering if there's any context that any of you have on this, particularly Ian, who's just gone off video, which scares me. Oh no, he's still there. Around the fact that the Red Hat container stack basically doesn't involve any Docker anymore, where you've got CRIO running the containers and Podman to manage them, BuildR to build them, in Scopio, whatever that does, I can't remember. Is it the push and pull thing? And they've kind of made a more distributed thing away from the Docker monolith. I was always taught that, well, not always, but in my history, I've seen examples of where monolithic tools give you problems with security. And it seems that Red Hat are going the other way. It's like these little single tools that do one thing very, very well, and you reduce your attack surface there. Do you think those two things are tied together, or not, Ian?
Yeah, I mean, it's the Unix philosophy, isn't it? Do one thing well, and Red Hat have set themselves up in opposition to the Docker. Monoliths are easier to build, and daemons are easier to build when you want to get a product out. But yeah, I was very interested in Podman and Builder and Scopio and so on when they came out, and I think I wrote a blog post about a year and a half ago where I talked about switching from Docker at home, because Docker was crashing on my home server, and I thought, well, I can either rebuild this or I can try out Podman and Builder, etc. And it was an extremely widely read post because I did actually manage to switch, but eventually I switched back actually because at the time Podman wasn't that reliable and was pretty limited in certain features. May well have changed now, but there's also CRIO as well, has been slipped under OpenShift since in the last year or so. And that's also a very interesting development because it tries to solve a lot of the problems that Docker has as well. So I think the world of container security and runtimes are becoming a lot more complicated and nuanced again, because people have had bad experiences, or the needs of consumers are becoming more sophisticated.
Yeah, absolutely. It's like the industry's kind of maturing somewhat, isn't it? And new tools are emerging to fight the perceived weaknesses of some of the others. Yeah, interesting side note from Pip. Like, yeah, that was the Linux philosophy, and then systemd happened. Yeah. Okay.
Let's not go there.
So
I'm curious to ask the other panelists in their experience. One thing I've experienced a lot is if I had a penny for every time someone said we should be doing scanning, then I'd
Scanning. Yeah. I always think scanning is always a topic. It's always a topic. What is the best tool to use for scanning? I think everybody wants it. Everyone wants it, especially as a tick box. Should it block a pipeline? I think it should. I definitely think that there should be more of a market leader, or more make it easier, as opposed to trying to investigate all of them at the same time. Normally you can see, which one to use or which one's best on the market. I think scanning is still free game.
I think scanning is really good to incorporate like in all of your repositories, and for sure have it in your pipeline. If you can, even like on the lower stages of maybe CI/CD, or having SDLC principles and having your images scanned and blocked from going to production when they have vulnerabilities, that would be great.
Yeah, and I think, sorry, go for it.
Some of the paid container repositories, like image repositories, have scanners in them, which is very helpful.
Yeah, so one of the things that I think is very important regarding to security and scanning is make it that door to production, right? Put it in the pipeline, as Natalie said. Make sure that nothing that doesn't have a certain level of security or a certain level of no vulnerabilities gets released to production. But even with that, one of the things that I have done in several places is keep scanning everything actively, and as soon as there's any of the pods or any of the machines that have a zero-day vulnerability or anything that is critical, it gets immediately isolated and removed as humanly possible, in the sense that we don't want to shut everything down at the same time, right? But keeping that balance in mind.
Yeah. Even in a dev environment?
Yeah.
If you have your pipelines automated enough, and you have your code going through tests and an image gets built, it gets deployed in a test environment, it gets scanned immediately, for instance, and then the result of that is a failure if there is a vulnerability. Or if you just have a pipeline that is automated to a sufficient level where if a vulnerability is found, then it's relatively easy to build a new image with a patched vulnerability. Then that would be helpful, and it wouldn't be too much of a burden for developers to kind of remediate on their security issues.
That hasn't always been my experience. If certainly working for a large bank, telling everyone, thousands of development teams, you've got to change your base image, would raise a huge groan at best, and loud complaints at worst. Yeah, I think that whole governance thing is it's often underestimated how much work that is. But another thing I'm interested in asking you guys is, you get a vulnerability report, and usually there's lots and lots of vulnerabilities in every image. how do you draw the line about what is acceptable and what isn't in your organizations?
That's very interesting. I suppose it depends on your tolerance to how sensitive your workloads are, how sensitive your images are. If you're running a CAD blog or dealing with healthcare data.
I think you do have to have a strict set of guidelines on what is tolerable and what is not, because deciding on the spot, I find is so you need to have a policy that you can go to, and someone that signed it off, that whose head will be on the block, where so you've got an agreed level of what can and cannot be done.
Yeah, that is the rub, right? That's the real problem. I think I've found is that getting someone to actually say anything over a 7, CVE 7 is a problem, or whatever. Actually being able to definitively say that's always been the problem I've seen. Also, if you read someone through a lot of these things, they're really nuanced, and you can end up having endless discussions about how risky is this and how likely is this, and it's just unsustainable if you have thousands of images floating around.
Yeah, definitely. But one of the, I would say that to me, it's a clear indication that there's no good framework of domain and responsibility, right? And that's one of the first things that we did in order to make sure that everybody was clear that even if the applications were completely and fully owned by the application teams, and we would have no opinion whatsoever about how they code the applications, that the key to production is everyone's responsibility, and there were certain rules of the game that everybody needs to follow. That took all these, I would say, all these discussions out of the way, because otherwise then it becomes an opinion of, oh, well, I think it's more secure, I think it's less secure. It's like, well, we have a scanner that is enterprise grade that everybody agrees in and the company has decided to invest in. And if this says that this is risky enough, it's not going to production, I'm afraid. So everybody knew those rules of the game. And I think that's very important, right? Rather than trying to enforce it through tooling and then have the discussion afterwards. And that creates the quarrel, that creates the disagreements. Just make sure that all the guidelines are published beforehand so everybody knows what they do expect.
It is much more complicated when you're dealing with a huge corporation. When it's a company with relatively smaller size and everybody can agree on something, or at least the leads can agree on something, compared to, like, I understand in the environment of a huge enterprise bank, that would be more complicated to get a policy that everybody follows and agrees on. That's a bit more difficult.
But required.
But then again, like, you have the generic SDLC guidelines and generic like CIS and NIST guidelines. Maybe something based on that could be more widely adopted.
And that's the thing. It's that flexibility between everybody being good at what they do and being able to take the decisions versus when we're talking on a big enterprise. And this one I'm talking about, it's a bank that had around 5,000 developers at any time working on the platform. It's a lot more important that there's very clear guidelines. And there's some people that take them all the way to the extreme. Like, you shouldn't have spaces after the lines, otherwise you can go to production, which, to be honest, is ridiculous. The code works anyway. But if you find a good middle ground where you say, this is the minimum set of things that we will ask from you to be able to go to production, it's nothing that is not unreasonable, and we're not being obnoxious or we're not being pushy. It's just, this is the minimum that you need.
One issue I found is in a machine learning product, when you got vulnerabilities or things that alter the outcome of the product, when getting sign off becomes a lot more difficult.
There's a great little debate going on between Pip and Glenn in the chat here about whether scanning should be an external thing. So my mind was wandering a little bit towards like compliance and thinking of, I don't know, PCI DSS and ISO 9001 and external auditors and that sort of thing. Do we see any sort of value in that? Or Natalie, have you just nailed it with what you just said?
I think external scanning is good every once in a while to tell everyone, okay, this and this, go and fix it. Sometimes we overlook things. Everybody does, but it's more important to have continuous scanning and continuous deployment, testing, continuous culture around development.
Yeah, the continuous thing is powerful, isn't it? It's if we look at why we do continuous integration, or why we've been doing that for the last decade or however long it is, it's so that this stuff doesn't come at the end. So yeah, I fully agree with that. It's like by all means get the auditors in and get them to do a scan at the end, but by that point you should be probably in a position where you know it's going to pass. And yeah, maybe you need to do it to actually tick the boxes. But yeah, there's not going to be any horrible surprises there. Anybody else got any thoughts on that?
It's always about the segregation and it's like the old testing thing. Originally, everyone used to test their own code, and then they said, "Oh, testing needs to be separated because or external." So now security needs to be external now. So but then it all gets brought together because you want continuous integration, deployment, and you want everything to happen all the time. Then separate at the same time, you want to separate teams, but also bring them together. So it gets this murky water in the middle.
Yeah, I'm now reminded of, I think, Elizabeth Hendrickson at Pivotal, as a story she told at DevOps Enterprise Summit last year about how she reduced defects and bugs by basically firing the testing teams and shoving that stuff left. It seems that there's an analogy here with scanning and with like not introducing vulnerabilities, in that if you could get people to understand right from the start, i.e. developers, what they should be aiming for, rather than sticking it right on the end, then you get into a better place. But it does sound like some of the tales Natalie, Brian, Andy, and all of you have said that there's the management acceptance of that sort of stance. Without sounding like Cassandra, it's like, no, we've got all the security problems, we need to fix them. Is a very hard one to tackle, right?
Yeah, the whole area of supply chain discipline is really tough, because developers don't want to use any image they can get from public repos. But of course, the ideal thing to do is everyone uses the same base image, and they're just fundamentally, that's so many problems come out of having to use a common base image. I don't want to use Yum, I want to use apt. I don't like Red Hat, I want to use Alpine. It's very difficult to keep everyone happy, and because the costs of managing those base images are centralized, they're seen as a cost, which means they generally don't get funding. As you know, all infrastructure teams are starved of funding, and I haven't got a solution to this problem, but it's one that I see everywhere.
I find also the issue is, it's where you draw the line on the base image, because you want to keep your base image as slim so your containers load quick. But at the same time, if you want a common set of tooling, because I found quite a bit is that our base containers are really big, and then which slows down the entire deployment process, or especially on spinning up containers.
I've got a controversial opinion on that, though. I'm not bothered about the size of images at all. I've literally almost never had an issue in production, an image being too big.
Busy dealing with that currently at the moment. But that's not on Kubernetes. It's on ECS, because ECS on a task, and because you only got 10 tasks, and you got a limited 20 gig, and you got a container that could be 1.5 gig, and then your container takes 7 minutes to start. So it's not quite the same discussion because it's on ECS and not on EKS, but that's it comes down to the size of the container and the size of the base image, and the different teams use different Python packages in their images that cause the base image to explode if you put it all together.
But if, yeah, I mean, obviously, yeah, you're right. If the image is huge and unique and has to be downloaded, that's obviously a constraint on deployment. But if everyone is using the same base layers and those base layers are fat, that can actually improve the efficiency of the deployments. And then you just have your little Python packages on top in small layers, and there's not a problem. It's something I often get into discussions with people, and they're obsessed with reducing the size of their containers. And I'm often asking, why does this matter for you? Why, what production issue you're trying to resolve by going through these hoops? And often it's just like, oh, I like small stuff. It's good to be small.
Now in ECS, the size of a container makes quite a big difference, because it's pulling the container at every time the task starts up. It's pulling the task and it slows it down. And because in a whole service you only got 20 gig in total, so if you have your maximum 10 tasks in 10 containers, the size of the image, when it downloads the base image, it uses up the space of allocated space. So then if you're putting stuff on your container as well, I suppose now with the addition of EFS, it's giving you extra space, so it allows you to think, but it still doesn't allow you to spin up too many big containers at the same time.
In a way, I would say, in my experience, the reality sits somewhere in between. The reality is most of the time imperfect, in the sense that there will be solutions, so there will be software that won't be available in Red Hat base images, or won't be available in Alpine, or won't be available in the best solution ever. And then you have to sit down and take the decision if you want to port that and keep maintaining that every single release, or if you want to use what's already available and maintained, and I would say keep that balance, right? So in that sense, I'm a big fan of devolving that responsibility back to the development teams, in the sense that you can use whatever you want. Well, A, you follow certain guidelines, everybody agrees, and B, there's no vulnerabilities and the scans go green. From there, whatever floats your boat, right? If you want to install a micro FreeBSD kernel inside a container, go for it, be wild. But at the same time, have in mind that by being wild, you're maintaining that as well, right? Don't come back to me and say my micro FreeBSD kernel exploded in my face, because I won't care.
Yeah, that's a good compromise to set guidelines and say, okay, you can use that if that happens. Red Hat base images provide the kind of like assurance higher directors and management likes, because we can just say, oh, we have a contract with Red Hat, they're providing us with base images, they guarantee that those images are secure and will be patched. We don't have to worry about that. So that's a good argument when the journey to containerization just starts. You can just say, okay, it's secure, we guarantee. Not we, because we can make mistakes, Red Hat guarantees. But they do tend to be quite fat, those base images. And I am opposed to Ian. I am a fan of smaller container images, just by principle. There isn't really a reason, unless you run ECS.
Yeah, and that's a very good argument. I said, I've seen companies use only Red Hat based images just for that, right? They can sign off, there's all the security patches and everything's wonderful. But I said, it all depends on what kind of model do you want to follow. If you want to follow a centralized model of security versus a distributed model of security, where everybody is responsible for security at the end. And I said, I I always say, or the way I try to approach things is that I want to give developers the maximum amount of leeway, the maximum amount of freedom, but with that maximum amount of freedom comes a maximum amount of responsibility as well. So they need to decide, how do they want to spend their time? Do they want to spend their time writing all that code? Or do they want to spend part of the time maintaining those images because they think they're cooler, right? So in a way, I would say it's a bit Machiavellian in the sense that I want to make the easy, or the good thing easy, and the less good easy is harder. But I would never tell someone to not do it. If they want to spend all that time, and that's something that the company is happy that they spend the time with, go wild. But I said, I'm not going to use my own time to maintain someone's crazy project.
This all sounds very complicated. Should we just go back to virtual machines?
What about portability? Fantastic.
Okay, I think we're about time. This has been a wonderful chat. I've learned a hell of a lot from all the speakers and Marco's presentation as well. Thank you also to everyone who's contributed to the side discussion that's been going on in the chat. That's fascinating as well, and save that for later and pour through it. Yeah, lots of food for thought. So everyone who hasn't said anything or not said anything in the chat, I hope you found that useful and interesting. If everyone just wants to come off mute quickly and just give a quick round of applause to our panelists, and I think they've well deserved that. Brilliant. Okay, so yeah, we're about done. So I just wanted to say again a massive thank you to Natalie and to Ian for coming on the panel at fairly short notice, to Brian for coming on the panel at massively short notice. Thank you so much. Couldn't have done it without all of you folk. It's been brilliant. And also massively to Marco for an excellent presentation. Especially good that it certainly gets me thinking. And I think again, we've managed to have a panel session that's been triggered very, very well by the talk and the demo that Marco did. And so yeah, massive thank yous to you, Marco, for doing that. So that's about it for us. Now for tonight, we're going to run again one more meetup this year. It's going to be early December. I can't remember the exact date we decided. We haven't announced it yet. Alex, Jack, can you remember what it was?
I think it was the 8th.
Was it the 8th?
It's the 8th of December. Yeah, Tuesday.
8th of December. We're going to special guest. Not that everyone who's on here tonight isn't massively special. Chris Bytart, one of the founders of DevOps Days, is going to be with us. So we're going to do a kind of combination of this sort of panel session combined with an Ask Me Anything type scenario. I'm not responding to that, Pip. So we'll be reaching out quite soon for questions, things we want to ask Chris. But that's for next time. Just want to finish off by saying thank you again to everyone who's contributed tonight. It's been an excellent session. I'm very, very pleased. Yeah, it's been great. So that's it from us for tonight. Enjoy the rest of your evenings. Massive thank yous again. How many times will you say thank you? It's just brilliant. So thank you. And we'll see you all again on the 8th. We'll get the invite out for that as soon as we can. I need to run personally, but I'm going to leave the room open in case you guys want to chat and socialise a bit afterwards. Apart from that, thank you and good night. Cheers, everyone.
Thank
Yeah, Matt.
Yeah.
Jackie's still awake.
you.
Yep, still awake, still here.
Nice.